Yeah, hi.
What is it? Hello?
Yeah, hi.
Yeah. No, I just want to. I'm just checking. Just checking. Good evening, everyone, and good morning, Meghna. We have our speaker today, Meghna Natraj, joining all the way from Mountain View, California. A small bio of her. She's currently software engineer at Google Brain. Previously, she worked at Bloomberg, and she's a graduate in computer science from Georgia Institute of Technology. We are excited to have you, Meghna. Uh, Welcome. Over to you.
Hi, everyone. My name is Meghna, and thanks for the introduction, Gautam. And I'm a software engineer at the TensorFlow team at Google in Mountain View, which is basically a part of Google Brain and which encompasses all research and development related to machine learning at Google. Um, and just sort of an overview of what I'd be going through and some tips that you should look into. If you guys would be doing the workshop, that would require Android Studio. So, if possible, you can get started and install it right now so that eventually, if when we get to the workshop, you would already have it installed. Another thing is I'm making an assumption that everyone here is familiar with deep learning and TensorFlow. So you don't have to be an expert or you don't have to know a ton, but just familiarity with what these mean would be useful. And I would like to keep this interactive. So if you have any questions, feel free to post it on the YouTube chat. Note that there would be a 2 minute lag. So if I can't answer the question immediately, it could take a few minutes or I would address them at the end of the talk. All right, let's get started. So the agenda today is sort of to give you an introduction to TensorFlow Lite and what that means. So when I say TFLite, it means TensorFlow Lite throughout the talk. Then there will be a 30-minute workshop where we'll actually take a demo that we have on our TensorFlow Lite repository and walk through an end-to-end workflow of how you can actually deploy that app and kind of run through an object detection model. The next thing that we'll do is we'll dig a little more deeper into TensorFlow Lite and how it actually works. And then we'll discuss what features have been recently released and how you can kind of maximize like your performance using TensorFlow Lite. Awesome. So what is TensorFlow Lite? So TensorFlow Lite is basically a lightweight. Let me just go through the slides. Oops. Okay, so what exactly is TensorFlow Lite? TensorFlow Lite is a machine learning framework for edge devices, which basically implies devices which are on the endpoints where people interact with or consume or produce data from. So that includes mobile and embedded systems. And so when you look at the entire ecosystem of all the products that you can possibly run software on, you have powerful workstations and desktops and servers and cloud, where you have a lot of resources, as a result of which you can run TensorFlow, which is a huge library for machine learning on these systems. However, on a lot of other millions and billions of devices, you cannot just use TensorFlow library as it is. So there was a need to come up with another optimized version, which led to TensorFlow Lite, which supports Android and iOS devices. That is all the mobile phones that we all own, and other devices which have operating systems such as like a Raspberry Pi or some hardware accelerators like HDPO. Finally, there's also another version called TensorFlow Lite for microcontrollers, for things that don't even have an operating system, but I'll we'll primarily be focusing on TensorFlow Lite, and specifically with regards to mobile and mobile devices throughout this talk. So why TensorFlow Lite, right? So why can't we just use TensorFlow? So as I just discussed, TensorFlow is for large devices. When it was initially designed and built, it encompasses a lot of features for training and inference and so on. And it's well suited for that purpose. And at that point, there was nothing that could work efficiently on edge devices. And that's why we have TensorFlow Lite. And to sort of also think about what the code base would look like, you can think of TensorFlow being this huge library where you can train and also run inference or prediction, whereas TensorFlow Lite is a small subset of it, which only helps you run predictions on devices and some other sort of miscellaneous features that may be added to it. So a TensorFlow Lite there's a lot of advantages to using TensorFlow Lite, and I'll be going over some of them. A very big advantage to sort of what a lot of people in machine learning, a problem that you might go through is if you're writing some, say you want to build a model, a common thing that you would have to think about is what's my choice of a deep learning framework or platform that I want to use in order to train a model. And that could range from JAX or MXNet, PyTorch or TensorFlow, Keras, Caffe, and there are plenty others. And it's not quite easy to just keep learning new kind of frameworks. So you don't have to worry about that with TensorFlow Lite. You would be using existing TensorFlow trained models. The only thing that you'll be doing is sort of optimizing these models so they can run on edge devices. So yeah, TensorFlow Lite is designed for the edge. So when I talk about edge devices, that is all these mobile devices. It could include phones and it could be your earpods, a Google Home or Alexa, and so on. All of these have some constraints. They're not constantly connected to a power resource, and you can't run complex machine learning models that can take time to give you inference or predictions. There could be connectivity issues related to connecting to the internet and so on. And there are also a lot of privacy concerns recently regarding phones or these devices constantly listening to some noise. So in the sense that TensorFlow Lite is designed for the edge is that it optimizes on all of these 4 features. And specifically, like say for example, privacy, because if you build a model, then it completely runs on device. And so you can basically go on like airplane mode and your model would still run. Whereas a lot of the current services that exist constantly need to call services on the cloud. So it is production ready, and it is currently running on 3 billion global devices globally. So it's used in a lot of existing apps that you might be familiar with, like Photos and the Google board for predictions, on cloud, on YouTube, and so on. And another cool thing is that there are a lot of TensorFlow Lite. It has extremely good documentation. There are a lot of end-to-end tutorials and models and applications that are already available on the website, and they cover a lot of machine learning use cases. So for image, common ones are like classification, style transfer, gesture recognition, and object detection, and text and speech as well. So to give you sort of an example, for image, there's an app from a company called QE where you can sort of learn how to dance. So you can build apps like that. For text, this is sort of a very recent app, or sort of a breakthrough, was being able to run mobile BERT. So BERT is a language model, and which can be used for like a variety of NLP tasks. And it was a recent breakthrough in NLP research. And there's another optimized version called Mobile BERT, which runs on TensorFlow Lite. And it's pretty cool. So if given a paragraph, you can see that you can ask any question, and it actually highlights the answer. And there are also speech applications. So this is sort of what uses TensorFlow Lite Micro, in fact, where you can see a model that can detect yes or no and change the color of LEDs. So there are a lot of cool applications that you can build, and all of these end-to-end tutorials already exist on a repository. So now that there are so many devices, right? So initially, when you look at TensorFlow, you would have like a Linux machine, or where you could just sort of pip install TensorFlow and just train and run predictions. But when you now involve all of these edge devices, then the ecosystem now expands enormously. So now you have Android, iOS, and also ARM for microcontrollers. So you need TensorFlow Lite supports basically all of these platforms. So it's cross-platform and works easily on all of them. It also has cross-platform API binding. So what I mean by that is, in all of these ecosystems, you would have to write some code for it to work. So we do have APIs to do so, and we support a lot of them. And it's open sourced. So just like TensorFlow, TensorFlow Lite is open source. So any code that's ever written would be available online for you to go through, to contribute, and to learn more about. So these are all the kind of cool features of why you should use TensorFlow, TensorFlow Lite, and sort of a summary of it is that it's a machine learning framework, just like TensorFlow and like, let's say, PyTorch and so on, but mainly built just for prediction on these edge devices. And it's smaller and it's faster, and it also makes the whole ecosystem easier to deploy models on the edge. So at this point, I decided that we could probably go ahead and do a workshop. I know that it could be a little inconvenient because it's a YouTube live stream. Again, if you have questions, feel free to just post it, and I can pause and go as needed. So what would we do in this workshop today? So I'll go over an object detection tutorial. So just to give you a brief about what object detection means, it's basically detecting the presence and location of multiple objects in an image. So if you can see on the right in the application, it's not only detecting that you can see an apple and a banana, but also detects the location by presenting like the bounding boxes. So the model that is used here uses a very common data set called the COCO data set, and it which has many images that are labeled, and the model that's used is MobileNet V1 SST detector. So the MobileNet V1 sort of is for detecting a classification or identifying an object, and the SST part is basically for locating the bounding boxes. And all of this is available on the TensorFlow Lite website in the links. Another thing to note is, throughout the presentation, I will be posting a lot of links. You don't have to worry about noting them down or anything. I will post them on the YouTube video eventually, so you can go through it later. Okay, so all the instructions for this tutorial is available on the TensorFlow Lite website. So you can also have that tab open while we're walking through the example, if that would help. So you can just open tensorflow.org/lite/example, and you can just select object detection. And because we're doing this demo on Android, you would have to select try it on Android. For any of you who might just be joining to kind of just watch, you don't have to, that's all right. You can sort of just walk through the tutorial as well. Okay, so I'm hoping that all of you were able to open the link. I'll just wait a few seconds more before I change the slide. Okay, so if you have the page open, the general overview of what we'll now be doing is we'll go over 5 major steps. We'll set up the entire environment that's needed for us to be able to kind of run this code. We'll build and ensure that it actually can be run on the you can actually run the project. Then we'll connect a phone, and then again build, and then just finally demo. Another thing to note here is given the given just the time constraints, I would mostly be using an existing model in which is already a part of the app. So you don't have to worry about sort of training and sort of building a model for it. We can go over sort of details regarding that a bit later. Okay, so the first step is setup. So I hope all of you by now would have installed Android Studio. If not, no issues. I'll give you guys a couple of minutes to sort of install and set up Android Studio. So the link is developer.android.com/studio, and based on the OS that you have, you can install sort of the right version. The setup can take about 2 to 3 minutes. So I'll just wait for about a minute before I continue. So while you guys install, if anyone has any questions, feel free to post it on the chat and I can answer it. So one user just asked, can we use TFLite on Arduino? Yes, in fact. There are some really cool, so the speech demo that I just showed, which basically had a model that was detecting yes/no, was actually running on an Arduino. And we, in fact, so all the examples that we have for Arduino use TensorFlow Lite Micro. And in fact, in Arduino, you can actually install the TensorFlow Lite example library. So you don't have to do anything. You can literally download Arduino and just, there are some instructions for that. And let me see, I will actually post that link in the YouTube kind of the description section as well. But there are a lot of examples. There are about 4 examples, which actually when I get to TensorFlow Lite Micro, I'll actually show those examples, and they're all actually running on Arduino and they're really cool. So yeah, you can run it on an Arduino. Okay. So I'm hoping that all of you have Android Studio installed. If someone is struggling or having issues or need more time, just let us know on the YouTube live stream chat. So the next thing is that you would have to download the actual code that you're going to upload to the Android Studio, which is available at github.com/tensorflow/examples.kit. So you can just open this link, and you can just click download and just you don't have to get clone or do anything. You can just download and that should do. Another question that I have is, TFLite also, does TFLite support training and backprop? Safe federated ML. So as of now, there is, so I'll actually go, I'll dig more like deeper into what TensorFlow Lite can do, but for now it cannot do training, and that's sort of why it was initially built, is to remove all of those features that you don't need while you're doing prediction. So for now, it doesn't support training, but there has been quite some demand for being able to train models using your phone. And in fact, there is one example where there was someone who worked on a sort of a project where you can actually do transfer learning. So technically not training, but yeah. So and also I think there is sort of research, or people are looking into whether we can sort of add training to TFLite. So sort of it could be that could happen in the future, but for now, no. Awesome. So at this point, if you've already installed Android Studio and you've downloaded the code, go ahead and open Android Studio, and your initial screen should look like this. And when you open Android Studio, click open an existing Android Studio project. And once you click that, navigate to this path, which would basically have the entire Android example. So that would basically be the examples repository that you downloaded. Under that, there's lite/examples/object detection/Android. So once you sort of reach that screen, and once you click on Android, you can just click open, and it would then load that project onto your Android Studio. So I'll just wait for about a few seconds here. So back to a question that was posted. Does it support training and backprop for, say, federated ML? Okay, sorry. So I think the question was very specific to federated learning. And I think federated learning is sort of a way where you can run inference or model. You can basically have models on, let's say, many devices and run inference. And it kind of adheres to the privacy constraints that user data is secure, and the model is, when the model runs a prediction, it only sort of stays in the device. But however, in order to also facilitate training, data is sort of grouped or in a way collected such that it can be used for training and then kind of loaded offline. And I guess we don't have support for that yet, because TensorFlow Lite currently only just focuses on inference. So I would say no. So I think that should answer that entire question. Okay. So the next step is, let's say you have loaded the project. You will build and run without connecting a phone to just see if there are no issues. So for that, in Android Studio, on the top tools bar, you should be able to select build and just rebuild your project. Once you do that, click on the run button, which is basically like a green button on top. Optionally, you can also select the toolbar run, and then you'll see an option which is a run with two full stops, and then you can select Android. And the expected output should be executing task and just task finished in the console below. If you don't see this, which I did not initially, and I had a couple of issues, that's all right. In the next slide, we'll basically go over some issues that you might face at this point. Okay, so yeah, so you basically have to rebuild the project and just click the run button. I will come back to the screen, but I'll just go to the debugging section for now. So a couple of issues that you would probably face is that you might see a Gradle sync option. So when I was trying to edit the code a little bit, it would show this pop-up often. So if you see that at any point, click sync now. That could be an issue. You could also have other Gradle kind of issues where you might have to upgrade it. If it shows a pop-up, feel free to do that as well. It shouldn't be an issue. If you find any errors like failed something, for example, two of the issues that I faced was failed to find target with hash string Android 28, or failed to install the following SDK packages as some license were not accepted. I was able to resolve that by going to tools in the top toolbar, clicking on SDK manager, opening SDK platforms, and installing whatever Android API that was in the error. So if it's Android 28, just look for API 28 and install it. Apart from that, if you see any other issue, feel free to post it on the chat. I'll probably wait for a minute before I proceed. And again, if you have any questions at this point, feel free to post it. Awesome. Okay, so another question that I see here is what type of Android devices is required to execute TFLite? From what I'm familiar with, any Android phone as such should work. So just Android in general is supported. As long as you have Android on your phone, TFLite should be supported. So that should not be an issue at all. I think it's more related to the operating system, the OS, rather than the device. So I'm not familiar with any issues that we might have with any specific mobile company. So yeah. Okay, so at this point, I will proceed to the next step because I know it would take some time. So again, just to go back, you should be able to you should be able to build and rebuild your project and also click run, and you should be able to see the task execution finished. Okay, so if all of that is good, you can go ahead and connect your phone. So how you would do that is so initially you would see, if you just look at the top right of your Android Studio, you will see that Android, so you'll see that it has no devices. And when you connect your Android phone, it should automatically either, if you connect multiple phones, and it'll sort of display that and let you select. But if you just connect one Android phone, it should automatically connect. I must warn you though that it wouldn't automatically connect, and you might have to do some more steps. But ideally, you want to show your phone that you've connected to show up. For example, I connected my Google Pixel and it shows up in this way. So debugging. So there's a really nice link here for debugging, which kind of covers, which is developer.android.com studio/run/device, and it'll help you sort of So I guess the idea is to enable your phone to enter debugging mode. Only then can you actually run an app. And in order to do that, there are two steps that you primarily need to do on an Android device. So this could vary based on which Android version that you have, but overall, the first thing is you just need to enable developer options. That just helps you to do just general debugging. So for that, you can just open settings and just search for build number on the top of your search. If not, you can also just click settings, go to about phone, and build number. And once you reach that, tap 7 times on the build number until you see sort of you are a developer, or just kind of a little pop-up. And the second thing that you need to do is, because you've connected your phone through USB, you also need to enable that additionally. So for that, you can again go to that you can just exit settings and again go to the search and look for USB debugging. If you sometimes look for USB debugging from a different kind of settings option, it doesn't show up. So again, just reopen settings and search for USB debugging, or you can just go to settings, system, and look for developer options and then select USB debugging, and you need to ensure this is enabled. At any point you see pop-ups saying or like warnings, just go ahead and say okay, and enable them. So enable developer options and enable USB debugging. Only then can you actually run your app. And most cases, I think everyone would have to do that, because by default it's usually off. Okay, so I'll get back to answering some questions for now. Okay, so I want to make a TFLite model exported from Microsoft Azure Cognitive Services like Kotlin. Can you guide or throw some light on this? There is one application that uses Kotlin, which is actually built by interns about a year ago. And it's basically for pose segments. So I think there was a demo that I showed where there was a kid dancing and there was like a reference app. So we have an application called Dance Like app. You should be able to search for that. That sort of gives you an idea of what that does. But sorry, I digressed a little. But with respect to the Kotlin app itself, let me actually look that up. So I think it's pose detection and Android. Okay, so I don't know if I can find it right now. Oh yeah, I did find it. So you can probably look for this thing called running PoseNet model on Android, or basically the article is called Track Human Poses in Real Time on Android with TensorFlow Lite. So I do remember that this used Kotlin, but I am aware of the fact that you should be able to we do have support for Kotlin. But again, I am not quite familiar with Kotlin itself, and I don't have more information regarding this. But I can probably get back to you on this in a bit. Okay. Oh yeah. I will go over how to convert an existing TF model into a TFLite model eventually. So that should not be an issue. Okay, so I'll just go ahead with the next step here. Okay, so the last step is that, let's say you have completed this, you can just on Android Studio click on the run button again. You can again rebuild, go into build and rebuild, and also then click run. And once you do that, you would probably see the following steps. And you might see a couple of pop-ups that might warn you that it's an outdated version, or that that this app has an outdated is supported only for an outdated Android version, or it's an unprotected whatever app, and so on. And it might it will also use your camera, but just go ahead and sort of do anything that requires minimum amount of effort. So just skip as many steps as you can. So if it suggests an older version, if you want to include any, like download anything, just say okay, actually, not install anyway. Just say install anyway. So don't send, continue, and then click OK. So if you see any of these screens, once you click run, you can probably use this as a reference to kind of walk through all of these steps until the app is loaded, and you can it'll just start up on your phone. You should be able to see it on your screen. Okay, so one user asked, what's the difference between TFLite and TFLite Micro? So TensorFlow, so just how TensorFlow is this huge library or just this code base for running models for training and predicting and models. TensorFlow Lite is a smaller version for only running inference right now on mobile devices and so on. And TensorFlow Micro is another even smaller version, which is sort of so just how like TensorFlow Lite is to TensorFlow. TensorFlow is to TensorFlow Lite. TensorFlow Lite is sort of another smaller version of TensorFlow Lite Micro is a smaller version of TensorFlow, and it's sort of built off of TensorFlow Lite. And a lot of things have been sort of like removed from even TensorFlow Lite to make TensorFlow Lite. For example, there's no OS. We don't use a lot of dynamic arrays and so on. So yeah, that's about the difference between TensorFlow Lite and TensorFlow Micro. Okay, so I guess the last step is the demo. At this point, you should be able to sort of point your camera to any object around you. So this is my screen and just the things that I have on my desk. And I just did this just 2 days ago. So yes, the app works. And you can see that it selects bounding boxes and might make mistakes like detecting my bottle as ways. Another thing that you can sort of mess with is that the frame rate is quite high, and it constantly makes predictions, and sometimes it's bad. I did see a little more stability when I increased the number of threads, so you can probably just explore, and also you can sort of move your phone to different views and see how it predicts. The COCO dataset has about 80 possible objects that it can detect. So as long as anything that you're pointing at is one of those objects, you should be able to see it. And that's about how that workflow would be. So until now, what we've sort of done is that we already have a TensorFlow Lite model. So somehow a TensorFlow model was converted to TensorFlow Lite, and all of the instructions were included as part of like this app, where when you build the second step, it was automatically downloaded and included as a part of your entire project. So you don't have to, we never had to worry about that whole process. But we'll eventually kind of discuss that as well. Okay, so I know that we spoke about why TensorFlow Lite is awesome, and maybe you have an idea about it, but you sort of still don't know how it internally works. Like, what exactly is the code? What exactly does it do? And so forth. Okay, so just before I get started, general idea about like understanding. So TensorFlow Lite is a machine learning infrastructure. So if you're coming from a machine learning engineering background, it's sort of like a tip of the iceberg where you're sort of looking at some code that might take some data set, train a model, and then throw some output. But to understand how TensorFlow Lite works, you would also kind of need to understand how TensorFlow works and like what exactly is happening in the background. And to sort of probably not an idea of what machine learning engineers sort of think you do is sort of just build a nice model that can make some predictions, but internally it's actually just matrix multiplication. So you have a graph. So a TensorFlow model is basically a graph which basically has three kinds of how I picture it is three kinds of operators. So you have the initial input and output, which are matrices. When I say matrix, it's sort of like a vector, which could be like a 3x3 with numbers. Again, it's all numerical computation. And along the way, you're going to train parameters. So it could be weights and biases and so on. That's what's technically a major like kind of component of your model. And or you're going to use operators or ops or kernels. I'm going to be using this term quite often throughout the tutorial, throughout the rest of the talk. So what that really means when people talk about ops or kernels with respect to TensorFlow is your actual I guess your TensorFlow layer, or sometimes it could just be like some math operation underneath that. It could be like addition, multiplication, and so on. So let's say you're doing a fully convoluted layer is an op. An add is an op, but you might not actually use it. But it could be used in an underlying math operation. Like one op can be composed of multiple ops. ReLU is an op, and so on. So even all of these layers that you're adding, they could be ops themselves, or maybe they might be composed of ops underneath. So now that you have an understanding of sort of the model itself, let's look at what we're doing, what happens in the entire ecosystem end to end. So you have a workstation, let's say, as a machine learning engineer, and what you might end up doing is you might drag in some data set, train a model, and then run predictions on a Jupyter notebook. So TensorFlow has basically all of this information that helps you do that, right? It helps you define a model where you can have these variable parameters. Initially, these weights and biases can be modified. You do some backpropagation when train it and update these weights. And there might be some operations like dropout and things like that for regularizing or making your model better and so on. So it kind of has this understanding of this entire ecosystem. The next thing what you want to do is, okay, hey, I've built this model, let's run inference or basically prediction. And you might want to do this on other devices, not just your workstation. And for that, TensorFlow has an understanding of taking that graph or that model, and then now once that it's trained, all of these are fixed parameters, and you can now actually take an input and run it through the graph again, and then come up with a prediction. So it has information about just the prediction related or inference related part of this entire workflow as well. But however, you can't just take a TensorFlow model and run it on mobile devices. And the reason is you might be able to with maybe some, but mostly not, because TensorFlow as a library is extremely large. It's like 55 MB. If you can just download it and just look at it, just try it out yourself. And that's quite huge. And most phones don't have the capacity to kind of you can't just do a pip install, let's say, in your phone and have this library. It's going to be laggy. It's going to be slow. And it's not a good choice. So then the goal was that, hey, let's just focus on what we want to do on these phones or on these edge devices. It could just be all you want to do is just, you have that graph, you just want to be able to take this input, which is in basically math or numbers, do a couple of bunch of matrix multiplication, and just throw an output. So that's literally what you're trying to do at the end of the day, and we'll sort of have just that information, and understand what these ops are, and also have support for only very few ops that might be used by most models. So for example, TensorFlow supports LSTMs and very specific forms of all of these cells, or ops, or bidirectional and so on. But TensorFlow Lite actually does not support a lot of complex ops right now. It supports a lot of these common ones like convolution, fully connected, and so on, and so ReLU, and so on and so forth. So just take all the important ones that are most commonly used, most use cases that we can solve, and just the important parts, and maybe add a little some extra features that might make running it on these devices better. Okay, so so now I'm just going to focus on, so from TensorFlow, we're now going to switch to TensorFlow Lite in context only. So what we want to do is we train TensorFlow models because we don't want to learn a new language. And we want to run inference on these mobile devices using something that we built, which can just understand a model and can give me an output. However, you cannot just take it was not possible to just take TensorFlow and just extract that inference part, because TensorFlow is a very tightly couple library, and like it had a lot of dependencies and things like that. So there had to be some modifications done. So in order to be able to use an existing TensorFlow model, TensorFlow Lite converter exists. So what it basically does is it is still a part of TensorFlow. It's a part of that huge 55 MB library. But right after you train a model, you can use the converter in order to convert it into. So the final ecosystem would switch into this, where you take a TensorFlow model and you convert it into a TensorFlow Lite model. So it uses something called a flat buffer, which is, I won't go into details, but a TensorFlow model can be like a save model or a Keras model and so on, whereas a TensorFlow Lite is another version. However, you don't have to worry about it. It could just be like any file that you have. You never have, basically it's not something that you have to worry about. So you take a TensorFlow model, run it through the converter, convert it to a TensorFlow Lite model, and now this can be understood by your on-device TensorFlow Lite interpreter. And usually you wouldn't have to, I guess, worry about how you would run TensorFlow Lite interpreter in all of these devices. So in order to understand how the entire ecosystem works, there is one example that I will mention at the end, which you all can try out, which basically does everything from training to actually writing code for the converter, interpreter, and everything end to end. So you can have a more in-depth understanding of how you would do it. So I will spend some time. So I know somebody had asked how do you actually convert TensorFlow Lite to TensorFlow. So I do have sort of an example. So this is for TensorFlow Lite Micro, but it serves as a very good example for explaining. Again, I'll be posting all of these links, so you don't have to worry about it. All the important links that I just went over. So I'll only go over, it's a very large tutorial, so I'll only go over the important parts so you can understand how you're converting it into a TensorFlow Lite model, right? So this is Jupyter Notebook, and what we're trying to do in this notebook is very simple. Given an input X, any input, which is a numerical value, which is a float value, sort of predict sign of X. That's about it. So you're just trying to output predict values in a sine wave, so all of this is sort of setup related, where you might where we install TensorFlow and import NumPy and things like that, other libraries that we might need. So I guess the goal is, this is your input, your x-axis, and your y would range from -1 to 1. So what we do is we randomly generate data in this and find the sign value, and then that's used as our input data. And some noise is added, so the model doesn't quite learn things perfectly. The data is split into training, validation, and testing. Again, all of this is a part of the training process, and I'm kind of very quickly going to skim through it given the time that we have. So when you get to the actual core of training, there are two sections in this notebook where we train a simple model and then a more complex model. I will actually just switch to the complex model part. So again, until now we've loaded some libraries and we've sort of prepped the data for training. And I'll just skip to the part where we train the second model. Just give me a second. Yeah. Okay, so over here, again, we train a smaller model, and sort of the idea of this notebook is to show that it doesn't work for a smaller model. And yeah, as you can see, the predictions were not good. So I'm just skipping to this part. So the second, the main model that we're gonna, the next thing is we're gonna define like a normal TensorFlow model, which has like two dense layers of fully connected layer, and then it just has again one single output, which is so this is basically regression, and just outputs a float value. So it takes a float value, outputs a float value, and it's just a very simple neural network. And then you train it, and once you're done training it, you can sort of run through the graphs and see, okay, it's done really well, and that's about it. Right. So until now, this is what most of you would do with respect to like any workflow like that you might have in your grad school, in your machine learning courses, or at your work, and generally you take the data set, build a model, ensure it's good. And this is where most machine learning like practitioners sort of end their work. At this point, they would just go run predictions on TensorFlow on a server or using some sort of serving platform. So if you want to take this model and then convert it to TensorFlow Lite, it's pretty easy. So it's just if you already done import TensorFlow, you will basically now if you remember the step that I had mentioned here is sort of, now that we finished this step, we now go ahead and build the model. We'll convert the model into a TensorFlow Lite model. So that would basically involve using the TensorFlow Lite converter, so TF.Lite sort of this library, which would help you convert the model so you can read multiple models. You could read a Keras model, you could read a Save model, so different TensorFlow formats that are available. Again, this only supports TensorFlow models. So whatever TensorFlow model formats are there, there are APIs to support all of them. So this is sort of the highlight, is that you sort of just run this. You sort of first read the model or like initialize the converter, and once you do that, you run this convert function, and that's it. You just have this model, and these are the only two steps needed for you to convert a TensorFlow model to a TensorFlow Lite model. I must warn you that a TensorFlow Lite does not support a lot of your complex like models. Like I said, like many versions of like most LSTM or like RNN models and so on. But it does support sort of many use cases. So many existing models that you can look up on the TensorFlow Lite website to ensure that it's actually supported. So yeah. That's about it. So you should be able to convert the model and just save it. And once you save it, you can sort of just deploy this on your Android app. So in fact, another thing I wanted to show, I am currently unable to show that. I guess what I wanted to show was that in your Android sort of project, if you go to app and assets, you should actually see the model that you ran on your object detection code, and it's basically called detect TFLite. Let me see if I can sort of just show it to you guys quickly. Yes, okay, so if you actually go to Android Studio, you should actually see your TensorFlow Lite model installed under app and assets. Like once you've already built and run, you can just go back and actually look, and you'll see a detect.lite, and you can actually run other object detection models. There's a lot of information in the example itself on how you can train and customize and use other models and so on. So this is the TensorFlow Lite. So at this point, let's say that you have converted the model, you can just go here and sort of replace the model here, and obviously you would have to change the code accordingly, and you should be good to go. So that's how you would actually convert. It's just like sort of 2 lines of code. And let's say that what you want to now, I'll get into more about like optimization and so on. But for now, you just want to convert an existing model as is. So I guess that's about it. It's just those 2 lines. Okay. So coming back to this. Okay, so maximizing, I might go a little faster here, and I will definitely answer all the questions. I'll stay a bit extra and go over all your questions. Okay, so maximizing TFLite features. So a lot of tips that I would give you I did work on sort of training models and sort of running this whole thing, and a lot of issues that I faced, and another that you might want to avoid. And the second thing is also TensorFlow Lite in the past year itself, they have released so many features that you don't want to you might want to like optimize your model performance. The whole reason you're doing this is because you want to be able to run a model very quickly, very accurately on these edge devices. So you should use all of these features and then look into them. And in summary, there are about 6 of them. The first one is picking the right model architecture. This is the first step that you will do. So when you look at models like Inception v3, I think it's like 95 MB in size. 95 MB in size. You might want to pick a model that is actually, a lot of mobile model architectures are being researched and papers being published. The most common one is MobileNet. There's MobileNet v1, v2, v3, I think v4 too, I'm not sure. Pick a MobileNet model, or EfficientNet or SqueezeNet, and there are tons of models which are kind of for like mobile devices. Pick those models. There might be a little bit of loss in accuracy, but it's much quicker and smaller size. The second thing that you want to do is, while you're training a model or after you've trained it, there are many optimization techniques that you can use. So one of them is basically called quantization. So it's reducing numerical precision. So when you have a model, all the weights that you're training, everything, your entire graph, remember the TensorFlow graph that I discussed initially, has these weights and parameters, like weights and biases, everything, and it's all in float values. And float is 4 bytes. And if you can sort of map these values, so if you have, let's say, values from 1,000, -1,000 to 1,000, and if you can map it down to just int8 values, which is -127 to 127, and so you would lose some precision, but you would get a 4x reduced model size by just changing the type of variables to int8. So that is what you're doing here, and this is a whole new subject, and there's a lot of information that I'm not going to discuss now. But that's sort of the gist of it, is that you're reducing the precision of the model by a bit, but mostly, in fact, the results have shown that models have the same latency or like the same accuracy without much like loss in performance. And it works well. There are also many other model optimization techniques where you can also do while you're training the model, and you can some that you can do after, called pruning and so on. So you can just check it out on like model optimization at TensorFlow. And you don't just have to do it for TensorFlow Lite, you can also do this for TensorFlow models in general. Okay, so the third thing is, let's say now you've taken this good model, you've optimized it as well, and now you want to run it on these mobile devices. So in fact, in a lot of Android phones, there are accelerators, and I'll tell you what accelerators are in a bit. So it's something called the NN API, there are like GPU, and like Android has all of these accelerators. And like what I mean by accelerator is like just how you have CPU on like your machine or like a GPU, even your mobile phones and all of these devices can have a GPU or other kind of execution environments. So what you can do is you can take your entire graph or this entire model, and you can take a part of it and delegate it or kind of hand it off to this GPU on your phone so that it runs quicker. So if you're doing matrix multiplication on a CPU, it would be much slower than doing it on a GPU. So though it sounds like it could be a lot of work of handing off and input output involved in this, if you have extremely huge models, then it gives an extremely good speed up, and I'll actually give you a summary of that in a bit. So that's sort of what this delegation is, and you would sort of do that when you're writing your app or your Android app or your app, and you would sort of look into all of this at that point. So these are, again, now the first three were sort of optimization or sort of techniques or in making a model better. This is sort of the next few steps are to just help you code better or understand your model better. So if you have built a TFLite model, you can actually run it and test. You can sort of do some benchmarking and profiling to kind of understand what is taking time and so on and so forth. So this is these are the commands that you can run. You can just look into benchmarking TFLite and kind of get this link and look into it. It requires installing Bazel, which is extremely difficult initially, but it's kind of useful if you would be doing this long term. And you can see that you'll see that there was some model here that we benchmarked just now, and it uses conv 2D layer, which takes about like most of the time latency, and then once you've identified this bottleneck, you can probably look into optimizing or maybe changing the model architecture and things like that. So it helps you just look into your graph. The last thing is easy mobile development or coding itself, right? So there have been a couple of libraries, in fact, just released in Google I/O like just this year, just a few months ago, which is, there are a lot of terms here, but in summary, it's called the Model Maker and the Support Library. So the main thing is the Model Maker, which helps you to actually write code, your training code for mobile development, and then you have your a support library which helps you do inference, and I'll sort of not go into them, but if you want to if you just look at a Jupyter notebook, I've just grabbed in some data in order to like do some sort to run a image classification model, and all the code from that this is just probably like just 1/4 of the code in order to do that image classification. So you would have to like read the data, like, and pre-process a lot of these images, like scale and flip and so on, maybe even change into float and scale and so on, and prepping up for training models. And then you define all of these model architectures, and then you compile, and then you actually train, and then you convert it to TFLite. So it's a lot of code to deal with, and for beginners, it might be really painful to do that. With Model Maker, I'm missing the import steps here. To import Model Maker, that's about 4-5 lines. But apart from that, it's just this much code. And what this is basically doing is it's taking a TensorFlow model, training, and then evaluating it, and then finally actually converting it to a TFLite. But you need to note here that this is not for normal TensorFlow, it's for TensorFlow Lite specifically. These steps basically help any new user onboarding to TFLite, understanding it, quickly code. However, some people might prefer the old method if they generically just like TensorFlow code or just like normal machine learning code. Similarly, at inference, if you were to write Java code for like on an Android app in order to do like classification for this like the model that we built, this is how it would look. You would have to like convert the images by some channels and pixel and process it, a lot of for loops. Whereas if you would do it using the support library, it's very simple. It kind of, you can define a class which has all of this information inbuilt, and you just pretty much a prediction. It again would not be just very straightforward 4 steps. You might still have to write a bit more code around it to make it work, but you can definitely look into those features. So in summary, pick the right model, look into model optimization techniques. Once you've like trained, you want to also optimize it. Then you can look into, when you're running it on device, use Delegate, like basically your mobile devices or your all of these other devices can also have GPU and so on, and you should definitely use them if you can. Like Android for sure has like NN API and things like that. You should look into benchmarking and profiling if you want to dig a little bit more deeper. And if you're new, you can also look into Model Maker and support library sort of features. You can just look at TFLite website, and you should be able to find all of this information. And in fact, with few of the optimization techniques, especially the first 3, the improvement in like when you used an optimized model on a CPU was like almost 2.x faster. On a GPU, it was 5x faster. On DSP or like microcontrollers, it was like 15.2x faster, and on an edge TPU, it was 38 times faster. So you can get a lot of improvements. This is for a MobileNet model V1. In the end, TensorFlow Lite Micro. I'm sorry, I'm running a little late. I'll probably take about 5 more minutes. Another thing that I just wanted to go over is I wanted to go back to that notebook, and I wanted to just show you guys if you were to do optimization. So we remember I mentioned quantization. So let's say you've already selected like a MobileNet model, and once you've trained it, if you want to sort of reduce the size of the model and latency, you want to convert float into integer, then you would run through some steps where you want to you define this converter, the TensorFlow converter, to optimize and to only have integer operations, and provide some data set that helps it to do this quantization technique. So with a couple of steps, and then you again run convert. You add a couple of steps and then you again run convert. And in fact, you can the model reduction is not much in this code, because the model itself is really small. The difference is just 224, but usually you would see at least a 4x reduction in huge models like MobileNet, if you were to use like one of these techniques like quantization. This is sort of like a go-to technique that you should probably definitely check out, even if not the rest. So yeah, that's about TensorFlow Lite, and I will get back to TensorFlow Lite Micro very quickly. TensorFlow Lite Micro is basically for microcontrollers. Microcontrollers are basically even smaller computing units which have no operating systems, very few kilobytes of memory, and it's everywhere. So it's in your refrigerator, it's in your microwave, it's in your washing machine, probably also listening to you on your phone right now. So it's just everywhere, and they have very small memory, and just very few like peripherals like IO, CPU, and RAM. So it's very like sort of low level, you could think of. But why even do TFLite Micro? Like, what's the aim? So the thing is, you don't, let's say you have a task like, let's say you say, hey Alexa, or okay G, and you want your phone to wake up. You don't want to use an extremely huge model running on, let's say, a CPU or a GPU and using a lot of power. So you can use TensorFlow Lite as a filter, you could say. So you let's say it's running on your phone and you want to wake the phone up. It could just detect if there is a sound or no sound, and if it does detect it, then it can detect is it human or not, and if yes, then you would want to actually wake up the CPU and wake up the model and then run inference. So this helps you to like save power, it will be quicker, and so on. So yeah. So for example, a hello world, why we call it hello world is like when you kind of write your initial first code for a new environment. So we just call it hello world, which is basically predicting the sine wave. And that was the example I just went over previously. That model is just 2.5 kilobytes, and there are many. So the right side is an Arduino. I remember someone mentioned, wait, it's not. I'll eventually show an Arduino, but there are a couple of microcontrollers here, which are doing different things based on the output from the sine wave. This is displaying a sine wave, and the others are doing, I guess, some sort of an LED displaying thing. There are a couple of other models that actually use TensorFlow Lite Micro. The left one is the Arduino. I know someone mentioned whether you can use Arduino. And the rightmost example is also using an Arduino for like gesture detection. And all these models are really small. It's just 20 kilobytes or 250 kilobytes. And they're able to do sort of mostly binary tasks, or like just predict very few classes. So you can use it for these use cases. And these examples all exist online and in the repository. Okay, yes, thank you. The one thing that I did want to mention is that the two go-to resources that I think would help you the most, there is a lot of information out there that can be overwhelming. So I would say your go-to should just be the TensorFlow Lite like website, just tensorflow.org/lite. You would have all resources there. Everything that I've ever like spoken about here, you should be able to find it. And if it is too overwhelming, then I would tell you it's just best to sometimes just sit down and code. And that would imply that you can actually use this code lab, which is, I can just actually open it and show it. Okay, I'm so sorry. I am not allowed to open it. Okay, I will skip that bit now. But basically, sorry guys. But basically, it's you can just look for code labs and on recognizing flowers with TensorFlow on Android. That is an end-to-end code lab where there's a data set and you train a model, you do transfer learning, Also, if you explore machine learning techniques, you convert it to TFLite, run it on Android. You also use all of these new features like model maker and so on that I just spoke about, do optimization. So it's and also write your application from scratch on Android. So it's just an entire end-to-end tutorial, and you would completely get an in-depth understanding of it. So just recognizing flowers with TensorFlow on Android should be another go-to if you just want to sit down and code and understand things better. Another thing is TensorFlow Dev Summit happened online due to COVID. This time, just I think about a month ago. All the videos are on YouTube, and you can just look for Lite, TensorFlow Micro sort of videos, and there's some cool information on all of the things I just spoke about, but more in depth. There's a free Udacity course on TFLite. I do recommend that you guys just try out the examples. It's much better. But if you're interested in looking into courses, there's that too. There's also a book for TensorFlow Lite Micro. Again, the website and the examples there should suffice, but if you're interested, there's that too. You can ask questions on TFLite at tensorflow.org. There's also a mailing list. And again, I'll post all of this in the YouTube video. Awesome. Thank you for attending the talk, even though it's probably 9 p.m. or 9:10 on a Thursday evening, which is practically Friday. And I hope this is a good starter and it was helpful. And I will get into answering questions, all the questions that you all have asked so far. So feel free to stay if you want to listen to that. And if you don't have time, you can always come back to the live stream, and I would have posted all of the information to all of the links that I've discussed. Or you can sort of pause the video along the way as well. So I hope I covered what's the difference between TFLite and TFLite Micro. Again, TFLite, you can just think of TFLite Micro as being a smaller subset of TFLite, if that helps, just code-wise or how it's structured. Can I use it with React Native or /Flutter? I actually remember, I'm not sure if I did end up adding Flutter, but there is a slide where we go over all of the languages that are supported. And so there are TensorFlow Lite has cross-platform API bindings with Flutter. Again, I'm not sure about React Native. So when it comes to React Native, I'm assuming it's more web-based. Again, I'm not familiar with that, so I'm not sure. But there's TensorFlow.js as well, if there's anything web-related. How to run a model trained using PyTorch. So for PyTorch, we don't support that on TensorFlow. This is only for TensorFlow trained models, precisely. It's just for TensorFlow models for now, and we don't have support for any other framework trained models. And maybe that could be something in the future where you can train models from any network, and you should have a common platform, and you could build that. I have shared. Oh, sorry. Thanks, Gautam, for sharing the tracking human pose detection link. Is it possible to train a uint 8 directly with Keras instead of float? No, actually. It's funny because I was actually looking into this. You would have to train like a float model, at least the so TensorFlow converter itself. So if you even want to build, let's say, a TensorFlow Lite model, you have to go through the converter you have to go through the converter no matter what. And from what I know, the converter only supports models which have very few types. It has to have float input and float output, or I think in 68 or in 32. So basically only like few float types. And also even throughout the ops, like so for example, if you're building the model, it would mostly require all float operations. But if you can post your reason for why you want to train it in uint 8 directly with Keras, then I can probably then help you why. probably give you more insight into it, because I'm not sure why you want to train it in uint8 and not in float initially. But let's say, I think the idea that you have is you want to train a model so that why at training time you want to understand the errors that it might encounter, training it in integer versus float. Because it's already lower precision. So you want to kind of incorporate this error while training. So for that, you have quantize aware train or incorporate the uint or int8 errors, basically integer errors that would happen while you're training the model itself. So in a way, internally, it's learning the uint8 representation. And once you've trained the model and once you convert it, then you would actually get the uint8 model, but which is optimized, and all of this learning happening in training. Anyways, I'm going to go to the next question. TF model on Docker container versus TFLite model baked in. Okay, what is better for an edge device like Raspberry Pi? Okay, so if you want to run it on Raspberry Pi, I think all of the examples just have the model baked in. From everything that I've seen, all of them actually have the model directly as a part of an app. You could use a Docker container. I'm not familiar with, I haven't worked on Raspberry Pi. I don't have much experience with Raspberry Pi, so I'm not sure. If I guess a Docker would be nicer, because then it's sort of incorporated and like you can sort of have all your dependencies included. So if you can use a Docker container, you should, I guess. I would always recommend using Docker over having it baked in. But again, it really depends on the use case. So yeah, I'm sorry if I did not answer that. When using a representative data set, are you using data from all the samples with the same, from all the classes with the same amount of samples? No, actually. So you need to understand that the representative data set just wants to have an understanding of your range of input values. So let's say you have an image classification data set, right? And you want to train an image model, and all images have values ranging from 0 to 255, right? So it quite doesn't matter if you have it just wants to know your minimum and maximum range of your input values. So for an image, if I give it like an image of just all dogs, all the values are going to range from 0 to 255. Versus giving it all images of cats, it's still going to range from 0 to 255. Yeah, so it quite doesn't matter in this use case. So mostly, no, it does not matter. I'm just going to come back to this. Yeah. So it does not matter if you don't have to kind of worry about all the classes and things like that, at least for now. I am sure there could be some biases with some classes. So let's say if you have sky versus ground, then maybe the colors on the images might only range from few values, then you might miss out on things. But it's a very, very corner case, and for now, for any example, I would just say for a simplified thing, just take any just randomize your input images and just take 500 samples or something like that. You should be good. What are your thoughts on power consumption with respect to TFLite models versus non-TFLite models? It will be useful to estimate runtime on battery powered edge devices. So from my understanding, TFLite models which are optimized definitely consume a lot less power than non-TFLite models, or just like bigger machine learning models. And I think it just stems from the fact like bigger models implies more operations, implies more computation, implies more power. And then that's sort of just the general gist of it. When you're trying to optimize, sort of picking smaller models is better, and TFLite models generally tend to be smaller if you're applying all of these optimization techniques. It will be useful to estimate runtime. So I think using the benchmarking tool might help estimate. So that's why I mentioned a benchmarking and profiling tool, is that you can select the target architecture like Android and like ARM64 that you'll be eventually running on, and you can sort of see an estimate of how long it takes. And so you said battery powered edge device. Okay. I actually, when I think about battery powered edge devices, it also includes microcontrollers. And from what I'm familiar with, it is kind of hard to estimate because the ecosystem is kind of a lot more complex. There's so many things where you have the interpreter, you don't know, like there's a lot of components that get involved. So right now there is no way to actually estimate the runtime on, like let's say microcontrollers or all of these things that are battery powered. Like I'm assuming you're talking about really small embedded devices. It is extremely tough, and right now we don't have tooling, but it's kind of a recent kind of like initiative or work, and in fact people are looking into it. There's something called TensorFlow Lite perf or TF perf, sorry ML perf. It's called ML perf, and they're also looking, like basically it's for machine learning performance estimation and building like this whole benchmark and then like tooling around it, because it's really difficult to estimate and perform and benchmark. It's really complicated. Everybody's doing their own thing. So there is an initiative for that, and they're also looking into the same for embedded and micro and battery powered devices, and maybe there could be some updates in the future about it. Okay. Okay. I will be stopping right now because we have taken 20 extra minutes. And yeah, thank you guys for attending this talk. Stay safe during the COVID lockdown. And if you have any questions, feel free to just post it on the YouTube channel, and we can also look into it later. Yeah, thank you.